So, what really makes a senior developer? I mean, really, it's not about mastering every single new framework that pops up. No, it's something way deeper. It's a fundamental shift in how you think. And today, we're going to explore that shift. This quote right here, it just gets to the heart of it all. See, seniority isn't just another rung on the career ladder. It's a total transition from knowing what to do to deeply, truly understanding why you're doing it. It's about building a mindset that can navigate pretty much any technical challenge with any tool. And this contrast is absolutely key. Focusing only on frameworks, well, it's kind of like learning a dialect that could be totally obsolete in 5 years. You're just always chasing the next new thing. But focusing on principles, that's like learning the rules of grammar itself. That knowledge is timeless and it makes you effective no matter what language you happen to be speaking. Okay, so here's our roadmap for this explainer. We're going to start with the research behind this senior mindset. Then we'll define what mental models even are, and I'll give you a practical toolkit you can use. Then we'll walk through how to break down any problem. And we'll finish up by looking at how all of this helps you think way beyond just the code. First up, the senior mindset. And look, this isn't just some fluffy career advice. The whole idea that experts think differently has actually been studied in computer science for decades. In fact, just take a look at the research. This chart shows just how many publications there have been on developer mental models over the years. It's been a hot topic since the 70s, so this isn't some new fad. It's a really well-established field of study into what separates the novices from the experts. So we know they're important, but what exactly is a mental model? Well, to put it simply, it's your own internal blueprint for how something works. Think of a mental model as your brain's own internal simulator. When you look at a complex system, you're not just seeing lines of code. You're actually running a simulation in your head, predicting behavior and seeing the connections between all the different parts. It's how you can reason about a whole system without having to execute every single line. And this is where it gets really practical. A novice gets stuck on the syntax, the commas and the semicolons. But an expert, they understand the semantics, the underlying meaning and purpose of it all. While a novice is rigidly following a tutorial step by step, an expert recognizes recurring patterns and builds a higher level, more abstract model of the problem. That is the power of a well-developed mental model. All right, now for the fun part. Let's build a practical toolkit. We're going to look at 3 really powerful mental models that you can start using today to make way better decisions. First up, the famous Pareto principle, or the 80-20 rule. The key here is to actively apply it. Say you're profiling performance. You'll probably find that 80% of the lag is coming from just 20% of the functions. Bam, that's your target. Or maybe you find out that 20% of your modules are causing 80% of the errors in production. Well, that's where you focus your refactoring efforts. It's all about finding that maximum leverage. I absolutely love this one. A one-way door decision is a big deal. It's highly consequential and really hard to reverse, like picking a project's primary database. You should spend a lot of time and research on that choice. But a two-way door decision, that's easily reversible, like picking some small utility library. You can just walk right back through that door. So please, don't waste a week debating a choice you can literally change in an afternoon. And finally, second-order thinking. Anybody can see the immediate result of a decision. But the real high performers, they see the results of the results. For example, someone says, hey, we can hard code this value to ship today. First order result, the feature is shipped, great. But then you ask, and then what? The second order result is that now, every single time a new country is added, an engineer has to manually go in and change the code. The system is now more brittle and a lot more expensive to maintain. This model helps you avoid that kind of long-term pain. Okay, let's get super actionable now. We're going to walk through a step-by-step model for tackling pretty much any complex coding challenge that comes your way. I mean, this is the big question, right? It's one thing to know about these abstract models, but how do you actually turn them into code? Well, the answer lies in a structured approach to problem solving.
So here's the secret. You don't actually solve big, complex problems. Nope, you solve a series of small, simple ones that, when you put them all together, achieve the goal. This skill, problem decomposition, is arguably the most fundamental mental model in all of software engineering.
And this is the framework. Now I want you to notice something really important here. The actual coding doesn't start until step 5. You have to understand, identify the components, break them down, and plan your attack before you write a single line. This kind of structured approach is what keeps you from getting overwhelmed, and it's how truly complex systems get built. So, as we start to wrap this up, let's bring it all together. The journey to becoming a senior developer, it's not about memorizing a bunch of APIs. It's about fundamentally changing how you approach your work. This right here is the core takeaway. Frameworks will come and go, languages are going to evolve, but the ability to apply principles like the 80-20 rule, to make sound decisions using one-way and two-way doors, and to systematically break down any problem, that is a skill set that will serve you for your entire career. So I'm going to leave you with this question. Think about your work tomorrow. Are you going to consciously apply the 80-20 rule to your task list? Are you going to identify a decision as a one-way or a two-way door? Or are you going to use that 6-step decomposition framework on your next ticket? Pick one, just one, and deliberately practice it. And always, always remember this. Clean, efficient, and robust code doesn't come from knowing a bunch of fancy tricks. It comes from clean, efficient, and robust thinking. Sharpen your mind, and your code will follow.